Okay. Well, that's, I think we can all agree that that's the greatest opening ceremony of any conference ever, period. You know, conference planning committees get together and they debate things like what's going to be the theme. And you can all read our theme there, and I think it's working out perfectly. So Fire Family, it's my pleasure to introduce our next speaker, the Honorable Ron Goode.
Thank you. Thanks. Okay. Thank you for inviting me. When I get done, you might not invite me back. That's all right. That was wonderful. But at the same time, that was a little bite, a little taste. When we put on our cultural burns, our workshops will go for an hour and a half. We have 100 people, if we have 200 people, if they all want to sing, if they all want to tell a story, they all want to talk, let them. That's what makes community. It's what allows us to be able to share with who we are. So this is the kind of coming in ceremony is what we're always looking for, what we want. I think I only have, a couple hours? 3 hours. 3 hours, all right. Let's see. Putting fire back on the land. Can't see if I see better with my glasses or with them out of them. A question I've often asked the agency folks, as land managers, an endeavor they pride themselves to be, can you live there? Can you live on the land you say you are taking care of? 13 years ago, I visited the Aborigine in Australia. Everyone told where and who they came from. When an Aborigine woman spoke, she asked, "Do you know who you are? Do you know who you are? We know who we are. We are at one with Mother Earth." She didn't tell her lineage. She didn't tell her tribe. She didn't tell her country. She told where she came from. We forget that. You see, they know they come from Mother Earth, and that is where they will return. They know their spirit came from Creator, and that is where it will return. They know their body and flesh is made of crystals and elements. They know water and fire make them who they are. Am I speaking about humans or Mother Earth? Without water, there is no spirit. Without fire, there is no passion. And yet, what do we discuss? ITEK. How do we implement that? How do we do that? Well, that was ITEK right there. Do you believe it? Do you believe in it? Do you understand the spirituality of where we come from? Is that what you want? Or do you have a conflict between your spirituality and what somebody else has? Those that are on the land. This is a little Noom story. I am Noom, the North Fork Mono. A long time ago, when the world was being made, Water, Paya, married Land to Bop, and they had a mischievous child, Koos, who was always playful, loved to leave fire everywhere. Water followed him around, sprinkling his trail. Then Land followed behind, covering up his tracks with flowers and fresh resources. What we know is our bodies are made of Earth's elements, and the majority percentage of our bodily makeup is water. We also know our blood is our soul. It is where our spirit lives. Without blood, no spirit, no life. With earth and water intact, our first tool, first offspring, was fire. The fire within is our passion. Without fire, there is no passion. We know that following a wildfire, the water returns, and then Mother Earth starts growing new trees. New plants, beautiful flowers. Our creation stories tell us about different animals and birds stealing fire from the sun, others taking it away from them to protect everyone. These stories tell about those who sought the power of sun, controlling it, misusing it, abusing it. Not the light, but the heat and the brightness of the white light, which led us to the making of fire and how powerful that became. When we do solstice coming up, we sing for 20, 30 minutes while the sun is trying to come up over the mountain. And when it does, it doesn't come up as a yellow light. It comes up as a white light. I don't know how religious you are, I don't know how spiritual you are, but in your Bible it talks about that. It talks about the white light. And then finally the sun comes up over the mountain and drops its ray right down on top of our rocks, right down on top of our marks that have been there for thousands of years. Missed a page. The new mono creation stories was passed down generation after generation, telling us when our people lived in the metaphysical world, when the world was being made by Tainawa Togopatu, our creator. Our people were animals, birds, insects, reptiles. We emerged and transitioned from the metaphysical world to the physical, bringing with us the spirits of our relatives, our pets, or our puk, as the Noom refers to them, are still a part of us. We know that Creator gave life to all beings. Therefore, all life is in relations to each other. In the metaphysical world, all people spoke to one another. They spoke many languages, but the language they spoke the best was the language of ecology. Fire is a tool the indigenous people use to ensure the betterment of their livelihood. A tool used for millennia to take care of their landscape, their resources. Fire, like water, is sacred. Sacred because resources and the land calls fire. Fire calls wind. Wind brings the water. They all work together, all important to the welfare of each other, important to the sustainability of each one's health. What's the difference between prescribed fire and cultural burning? Discussions take place daily. Every conference, presentations, every Zoom, every interview, the question is, what's the difference between prescribed fire, control burn, and cultural burning? The answer is simple. Simple to the indigenous people of the earth. Not so simple to the agency land managers. Why? Because of the word fire. Flame has only one meaning to the land manager. But to the indigenous people, flame and fire is only a flicker of light off in the distant night. Cultural burning is about culture. Cultural means to cultivate, cultivating our culture. Why is that so hard to understand? But yet it is. Regenerating tribal traditions. Cultural burning is regenerating our tribal traditions. The emphasis is that cultural burning is not about the fire that we light on the ground. It's about the fire we light within the community and the culture. The fire we light on the ground contributes to the sustainability of our culture and for Native Americans as a whole. Centering culture. Culture is always at the heart of a cultural burn. The North Fork Mono ensure this through the presence of elders, children, neighboring tribes, basket weavers, medicine practitioners, and other cultural practitioners. Burning is not an ecological practice, is not just an ecological practice, but a cultural one as well. Cultivating the resources for food, medicine, and cultural materials. Burns are always started in ceremony, and the objective of the burn always center culture and the plant resources of importance to the tribe. Extensive site preparation. Since the suppression, oppression, repression of Native peoples of California and their fire, much land on which the North Fork Mono burn has not seen good fire in a long time. The land, the This has led to the overgrowth and buildup of fuels. Therefore, sites receive extensive preparations to clear or break down large fuels, clip heavy bushes and other plants, create fire breaks, and move fuel away from hazards. This extensive preparation ensures a safe burn. Creating a nutrient. After a cultural burn takes place, it is a crucial step to mix the resulting ash with the surrounding underlying soil. Fire breaks down the nutrients in the burned plants, and mixing the ash into soil reduces the loss of these nutrients to wind and rain runoff, allowing plants which regrow post-burn more ready access to the recycled nutrients. It has also been observed by the North Fork Mono that these mixed soils retain water better over time than soils which were not burned or mixed. Focus on return. The meaning of return in this context is twofold. To both return to the site and to observe the return of the plant resources after the burn. All cultural fire is done in service and stewardship of the land and for the continuation of cultural practices. The necessities returning to sites frequently throughout the seasons. Certain resources under the right conditions can return to the site within 1 to 2 months. This is expected by the burner. Observing, harvesting, and using the plants that have returned and been renewed gives cultural practitioners a unique insight into the state of the plants and the effect of fire on them. Understanding what is cultural burning. What we see out there on the front line is the inability for agencies to differentiate what is flame or fire. They claim their policies cover all fire, but none of the policies include cultural burning. We are in the last hurdle at this time. It is a power struggle. Parks, forest, CAL FIRE are igniters and suppression fighters, not burners, definitely not cultural burners. Yet the land begs for cultural fire, for good fire. Good fire is about rejuvenation, restoration, regeneration. Rejuvenation of the landscape, restoration of the cultural resources, and regeneration of the water, the spirit of the land. Fire is put back on the land with care and passion, burning only what needs to be burned, not igniting the whole country on fire. After 30 years of burning, we have never had a fire escape. Some forest firefighters lose 3 to 5 fires a season. These escapes are only 5 to 20 acres. So therefore, they go unreported. Only when it burns down a town, then it's talked about. Do these fire igniters get fired? Of course not. Prescribed fire is about economics. An agency gets paid by the amount of acres they burn. They get paid by the tree product they burned to improve its economic health. They want the removal of all underbrush, the cultural resources, the foods and medicines the Native American birds, animals, insects, and what the larger trees live on. And there lies the difference and misunderstanding about what flame and fire is all about. So again, I ask, can you live on the land the land managers are in control of? Would you survive? For how long? Could you thrive off the land in the condition it now is in? Consider the fact the indigenous people of our great land thrived for thousands of years. And now we have to fight the policies and politics to keep our culture alive. As one elder recently said, she is tired of hiding, trying to gather her resources to make her baskets. For nature's food, our bodies crave so much. For the medicines needed for the animals as well as our illness. Hiding because she doesn't want to end up in jail for keeping her culture and traditions alive. If you don't understand that, because I don't understand it, I have a master agreement with the with National Forest to do cultural burning. In the first 5 years, I didn't do any cultural burning. The second time I signed it, I said, I'm going to burn. And so we restored 5 meadows this summer, and all my piles are ready to go. And the man who signed it, the supervisor, said, if you light a match, I'll have you arrested for arson. If you light a match, I'll have you arrested for arson. I said, yeah, but you signed the contract. Doesn't matter. It will one day. But still, here we are. If the children are our future, how do we pass that down to them? As our ancestors and elders have passed down generational indigenous knowledge to us, the forced closed roads, closed trails, took away access, not only for the indigenous people, but for the animals as well. Today, when a wildfire comes, the animals seek dense shelter amongst the brush, hiding. After the fire, that is where we find them, burnt like everything else. Thank you very much.
Thank you, Chairman Goode. There's how do you set up a plenary? What's the goal of a plenary? Our team thought about it a lot, and part of it was getting at this igniting something that would be provocative and something that would hopefully evoke passion and that would stimulate conversation for the remainder of your week. Not to put any pressure on you, Rachael. But our next speaker is Dr. Rachael Nolan, who's a senior research fellow at the Hawkesbury Institute for the Environment at Western Sydney University. We've tried a couple times to get Rachael, and we're really excited that she's here today, and please welcome her.
Thank you. All right, I want to begin by thanking the organisers for inviting me to present today. And I'd also like to take a moment to acknowledge the traditional custodians of the land on which we're meeting. And I'd also like to acknowledge the traditional custodians of the land on which I live and conduct my research. I live on Camaragal ground, which is part of the Eora Nation, which is also known as Sydney. And today I'm going to be presenting research on wildfire regimes and climate change, and I'll be presenting examples from Australia. To start off with, I just want to spend a little bit of time talking about this concept of the fire regime, because it is so fundamental to the field of fire ecology. And so in preparing this presentation, I had a look to the literature, and I found this great paper by, sorry, dealing with nerves, here we go. But I found this great paper outlining the etymology of the term fire regime. And it really surprised me to hear that it had quite a long history. And originally it actually had quite a pejorative connotations. So it was originally coined by French colonists and French colonial botanists working in Africa in the 1800s. And they thought of the fire regime as something that was quite a negative impact on African vegetation and negative impacts on crops. And so since then, the term has evolved quite a bit, and its current usage is attributed to an Australian ecologist, Malcolm Gill. And importantly, Malcolm Gill highlighted that plants are not necessarily adapted to fire per se, but they're adapted to the fire regime. And so the fire regime has many components, but there's typically a spatial component, so area burnt. There's a temporal component, so the fire frequency or the fire interval. And increasingly in the literature, we're seeing the emergence of fire season as a really important component of the fire regime for determining how plants and animals will respond to fire. There's other characteristics of the fire regime which are important as well, namely fire intensity, or its analogue, fire severity, and also the type of fire. So is it a substrate fire that may burn over winter in peat, or is it an above ground fire? So how then might climate change be affecting fire regimes? So I think there's really three key determinants of fire regimes that are changing with climate change. And the first is elevated carbon dioxide in the atmosphere. And so this is hypothesised to lead to an increase in biomass production and therefore an increase in fuel loads. And the reason for this is because when plants open up their stomata to take in carbon dioxide, when you have high amounts of carbon dioxide in the air, they can pull more carbon in. And so the theory goes that they can grow faster. However, colleagues of mine at Western Sydney University have found that when you pump extra carbon dioxide onto a native forest, while you do get high rates of photosynthesis, the plants actually just push all that carbon back out into the atmosphere. And the hypothesis for this is because the plants are actually nutrient limited. So these are soils that are low in phosphorus, and they actually just can't grow any faster even if they wanted to. So with this example, it's a little bit ambiguous whether or not elevated CO2 will lead to increased fuel loads or no change in fuel loads. And of course, changing fuel loads have consequences for fire intensity and fire frequency. We can take a look at temperatures. So elevated temperatures may lead to increase in biomass production, but also increases in biomass decomposition. So it's hard to know if increased temperatures will lead to increased fuel loads, decreased fuel loads, or no change at all. Increased temperatures are most likely to lead to declining fuel dryness, and this is important because the moisture content of fuels is a good predictor of whether or not a fire will get ignited. And then, of course, temperatures have important consequences for fire weather. So with increasing temperatures, we're starting to see more of those extreme fire weather conditions that drive those big fire events. And then finally, rainfall patterns. So depending on where you are, we may see increases or decreases in rainfall, changes in rainfall intensity and rainfall seasonality. So the point I'm really trying to make here with this slide is that it's really complicated to try and understand how climate change is affecting fire regimes, and many of the mechanisms are antagonistic. And of course, we're not operating in a vacuum. Humans are not just affecting climate, we're affecting all sorts of things. So we've got changes in land use, we've had cessation of Indigenous land management, invasive species, and so on. And so I really like this quote by Keeley and Siffard in their 2016 paper. And they say that predicting fire regimes under climate change is not rocket science. It is far more complicated than that. Nevertheless, we are seeing that fire regimes are changing, and I'm presenting here an image from a paper by Duane et al. From 2020, and I'm really excited to see that she's speaking in this conference. And what this map shows is the frequency of extreme wildfire events over 2016 to 2020. And they describe an extreme wildfires event as an unprecedented area burnt in a given fire season. And in today's presentation, I'm going to be focusing in on this part of the world in southeastern Australia and the 2019-20 Black Summer bushfires. The Black Summer bushfires are really a bit of a misnomer because the fires actually started at the end of winter, which was quite unusual. They burnt all through spring, all through summer, and then they only stopped when we got significant rainfall. To give you a bit of a snapshot of the season, we saw over 7 million hectares burn of predominantly temperate forests. So these were predominantly forest fires. We had 33 deaths and over 3,000 properties were destroyed. And it's estimated that 0.67 petagrams of carbon dioxide were emitted to the atmosphere from these fires. Now, I don't know about you, but I find it really hard to conceptualise how much that is. So to put this into context, Australia's carbon emissions without fire are estimated at 0.49 petagrams. So 0.67 by any extent is a really nationally significant event for us. And we can see in this animation that was produced by NASA, this is looking at the black carbon that was flowing through the atmosphere during November of that particular fire season. And remember, this fire season went from, late winter all through spring and summer. And so their smoke plumes from these fires, they actually circumnavigated the globe and ended up back in the west coast of the country. They turned the glaciers in New Zealand brown. And there's this paper recently that came out that hypothesised that the smoke from these fires may have actually made the rare triple-dip La Nina that we subsequently saw more likely. So after the Black Summer fires, we had 3 La Nina events in a row, which is quite rare. And it's hypothesised that it may have been due to, or may have been more likely due to the smoke from these fires affecting the atmosphere. And so if true, this really points to the international significance of the fires. And so for Australia, La Nina events bring flooding rains, and we had record-breaking floods following a record-breaking dry period. I'm going to move on now to talk a little bit about what the determinants were of this fire season. And the work I'm presenting here is work that was done by myself, but also a number of colleagues in the New South Wales Bushfire Risk Management Research Hub. So we were a collaboration at the time of 4 universities that were tasked by the New South Wales State Government to provide the independent research to answer some of the key questions they had in an inquiry about the fires. And so some of the questions they had were simply, what was the cause of these fires? Was it climate change, or was it land management, or some combination thereof? So we can take a look at some of these 4 factors that we touched on before that drive fire regimes. So if we start off looking at fuel load, what we're looking at here is a graph of estimated surface fine fuel loads through time. And so what this graph shows is that there's a little bit of fluctuation through time, but immediately preceding the fires, there's no evidence that surface fine fuel loads were anomalously high. And so this is important because in Australia, one of the key ways that we manage bushfires is through prescribed burning to reduce these surface fine fuel loads. So this suggests that land management was not the root cause of these fires. And so it's not to say that it wasn't important in particular circumstances or particular local fire events. And it's also difficult to touch on what the long-term effects were of the cessation of Indigenous land management, and there's really not enough information to talk about that, and I'm certainly not an expert to talk about that. But essentially what this shows is fuel loads were not on land management, not the reason we had these fires at that particular time. But when you start to look at climatic factors, we see a different story. So we can look at the moisture content of live fuels, and so these are estimated from satellite imagery. And they show that live fuel moisture content was the lowest on record. Similarly, we can look at vapour pressure deficit. So that's calculated from temperature and humidity, and it's a good predictor of the dryness of dead fuels. And it also indicates that dead fuel moisture content was the lowest on record. We can also look at fire weather. So in Australia at the time, we used the Forest Fire Danger Index, and it also shows that weather conditions were off the charts. So we had the highest FFDI on record. Another question we looked at was what was the cause in terms of the ignition of these fire events. So there was a lot of rhetoric at the time about, arson, and we've got to lock up the arsonists. But in the months following the fires, we looked at data collated by the New South Wales Rural Fire Service on the causes of the ignitions of the fires. So for the fires where they could determine the ignition source, we found that the amount of area burnt by arson was only accounted for less than 1% of the area burn. So it really doesn't point to arson being a driver of this fire season. Power lines, which had been important in igniting big fires in previous seasons in Australia, were only estimated to account for less than 0.1% of the area burn. So these were not very significant in this fire season at all. Interestingly, backburning, so this is what fire crews do to manage fire events during fire season. Backburning was estimated to account for 11% of the area burnt. But really the key takeaway message here is that lightning was the main cause of these fires. So what we had 2019 was the driest year on record for Australia. Fuels were in a critically dry state. We had extreme fire weather conditions. And so essentially the landscape was primed for fire, and it just took an ignition source. And what we had these bands of dry lightning storms across the southeast of the country multiple times, and they just dotted fire ignitions as they went. And there were just too many for fire authorities to get under control. And so that is really what was the cause of these fires. So it's natural climate variability overlaid with climate change. I've talked a lot about area burnt, so I just want to touch briefly on other aspects of the fire regime. So we can look at fire interval here. And so this is a map showing the vegetation threshold status immediately before the fires and then immediately after the fires. And the main thing that you notice is there's a lot more orange on the map after the fires. So what that suggests is a lot of our vegetation type is now vulnerable to being too frequently burnt to recover from future fires. And so this really just brings me back, I think, to the theme of my presentation about fire regimes. So the fires themselves, although they were unprecedented in size, they were not necessarily a negative impact on vegetation, but it's what we'll see in subsequent fire seasons, because so much has been burnt. If we go back to a normal fire regime now of normal frequency, then a lot of these areas will be too frequently burnt. And so they're really setting up a legacy of potentially negative impacts into the future, depending on what we see. And so we can also look at fire intensity or fire severity. And this is work done by a colleague of mine, Luke Collins, who found that, interestingly, there was no evidence for a change in the proportion of high severity fire. But because of just the sheer amount that burnt, there was a record area of high severity fire that we saw. I want to move on now to talk about what the impacts were of this fire season, and I've very deliberately picked these two contrasting photos. So on the right, what we have is a hill slope that's suffered serious erosion after the fires, and this vegetation is really struggling to recover. But on the left, we have this really incredible display of pink flannel flowers, and I took this photo in the Blue Mountains World Heritage Area. And so this is a species that hadn't been seen in the area for decades before the fires. It had been lying dormant in the seed bank, and the fires triggered that species to germinate, and we saw this incredible floral display. And so really the point I'm trying to make here is that the impacts are both negative and positive. And so a quick overview of the season. An estimated 1/3 of Australia's plant species were estimated to have been burnt during the fires. Over 800 vertebrate species were estimated to have been impacted, including the iconic koala. And over 14,000 invertebrate species. The real story, though, with invertebrates is that we just don't know enough about their life history. Many remain undescribed, we don't know how they respond to fire, and so it's very difficult to know if fire impacts are positive, negative, or neutral for these. And finally, with aquatic systems, we saw significant erosion in many cases affect the water quality, and we had a number of fish kill events, and in some cases, thousands of fish were estimated to have died. I want to move on now to talk about a specific example of research that I did following the fires. And so I'm going to talk about resprouting eucalypt forests. So resprouting eucalypt forests, they're the dominant forest type in Australia, but there's actually many different types of resprouting eucalypts. And there's hundreds of eucalypt species that have this response. And so this is a photo of a forest that had its canopy completely consumed during the Black Summer fires. And you can see this really amazing fuzzy epicormic green growth up and down the trunk into the branches. And so that is an example of a forest that's really healthy and recovering as we would expect. And then this is an example of a forest that has a significant amount of top kill, so it is not recovering as we would expect. We don't say that the trees are necessarily dead because they may still have resprouting from below ground storage organs, but the above ground part of the tree is dead. So about a year after the fires, after we'd had significant rainfall, I went out with a field team and we looked at how these forests were recovering. And you could get a bit of a sense from these photos about the structure of the forest. So we have small trees, in some cases bigger trees, in some cases quite dense understory. And we measured a whole bunch of things, but in the interest of time, I'm just going to be focusing on the response of the trees and the above ground carbon stocks. And so what we're looking at here is 4 different types of these resprouting eucalypt forests. And we're looking at the amount of top kill in forest that was unburnt, forest that had an understory burn, or forest that had a canopy burn. And the key thing I think that stands out here is there's this one particular forest type where top kill was over 50%. So for these forest types, that is actually quite high. Normally top kill is more around 20%, and that's what we see with these other 3 forest types. So the reason this is important is because if you have a higher amount of top kill, then those dead trees are then more likely to be consumed in subsequent fire events. So then that has implications for fire emissions and frequent fires. So it's really just coming back to the theme about the impacts of these fires are still to be felt in subsequent fire seasons. And you can see, for example, here, this is footage taken during the Black Summer fires from a helicopter. And even though we have quite a sort of low intensity surface fire, this tree, which has a lot of dead biomass, it's producing an incredible amount of smoke. So I think this really raises the question of, well, why did this one particular forest type behave so differently? And so if we have a look at this top photo of epicormic resprouting, this is what most of our eucalypts look like. This is healthy resprouting, so this great massive fleshy new growth. And when we went to visit this particular Western Slopes dry sclerophyll forest, what we saw was on that bottom photo. And so speaking with local park staff, what we think happened is this forest had been subject to the worst drought on record, then it got hit by fire, then it did resprout, but then these guys, sawfly larvae, for whatever reason, came in and were able to chew down a large area of these epicormic shoots, and these forests just weren't able to resprout again. And so I think this really drives home the importance of when we're trying to understand how vegetation is responding to climate change. It's not just shifting fire regimes, there's other disturbances as well that are coming into play. So severe drought and potentially insect herbivory. I just want to touch briefly on the drought because this is the other big story of the fire season that didn't quite get as much attention. And so these are forests that have not been burnt. This is all drought stress. And so we were quite alarmed when we started seeing this. We haven't really seen this sort of widespread drought stress in Australia before. And so we went out and we had a look at how the forests were recovering. So this is data showing the percentage of dieback for a number of forest plots that we surveyed immediately at the end of the drought in 2020 and then a year later. And so we'd had that really significant rainfall, so if the forests were going to recover, they should have been able to recover by then, or at least show signs of recovery. And what we found is that they weren't recovering. So it really points to how significant this drought event was. I just want to finish up this final section of the presentation by just having a little bit of a look to the future. And I've deliberately picked this photo. So this is the floral emblem for New South Wales, where I'm from. And this is a photo that I took after a prescribed burn. And so these flowers are doing really well. So that the flowering was actually triggered by the fire. And so again, it's just coming back to this idea that fire impacts are not simple. They're not necessarily negative or positive. It's very much dependent on the taxa and their responses. And I think for me, reflecting on the Black Summer fires, what it showed me is that we still need fundamental fire ecology research, and we need it more than ever. A lot of our forest types that we thought were resilient are maybe not so much, and so this really brings home the importance of fundamental research. Some of the questions I have are, how likely is this resprouting exhaustion? So how likely are we to see these plants that are normally quite resilient? What are their limits? One of the questions that I think is a little bit more generally applicable to vegetation types globally is, how is climate change going to affect post-fire recovery? Are we going to see faster recovery rates because we have higher temperature and higher CO2 and potentially faster growth rates, or perhaps not? And then finally, this last question is something that's really come up for me quite recently, and it's this question of how is our vegetation responding to these increasing cycles of dry, wet, dry? And the reason this has come up is because in 2019 we had the worst drought on record, we had 3 years of flooding rains, and now this last spring, so the austral spring, we've just finished spring, we've had drier and hotter conditions than usual, and we're again starting to see members of the public are sending us photos that look like this. So this is again drought-stressed forest. And this is actually quite alarming to me because these forests should not be responding in this way after just one dry spring. It's quite surprising. And so it leads me to wonder, are they still struggling from the drought 3 years ago? Or are they struggling from perhaps waterlogging? And these are really fundamental questions that we just don't have the answers for. Lastly, I just want to finish on what gives me hope. And I've included this because I'm conscious that when we talk about climate change and fires, it's very easy to feel overwhelmed and to focus on the negatives. And I think for me, what gives me hope is that after the Black Summer fires, there was a lot of willingness and openness in the general community to discuss how we can manage vegetation better and perhaps do things differently. And one of the suggestions that's come up is potentially re-engaging with traditional land management and particular cultural burning. And so if we do see a way through this, then cultural burns will implement a very different fire regime to the one that's been imposed post-colonisation. So cultural burns in the Sydney Basin where I'm from, they tend to be in a different season, they tend to be a cooler burn, and they also tend to be more frequent. And so this is a photo of a cultural burn being conducted on the south coast of New South Wales. And then last slide, I have many different funders to acknowledge, and I'd also like to acknowledge that the work I've presented is not just my own, it's a whole host of many different contributors. Thank you.
So we have time for a couple quick questions. And if you raise your hand, and Jeff will bring the microphone to you.
Good morning. Can you hear me?
Morning.
I just have one question and just one comment. I'll start with a comment, which is California struggled with a pretty severe drought a few years ago where we saw a cumulative effect of the drought when it pertained to fire season, as well as for catastrophic wildfire, as well as prescribed fire, and the effects of that, and this new regime of what we can expect to occur from the brush, from this cumulative effect of the drought that occurred years ago. So we're still seeing that today.
Yeah.
So it's not like we get a good wet season and it's all over, right?
Right.
It's just not like that. And
Yeah.
we've realized that in the fire service and prescribed fire service. So we have data and studies on that we can hopefully help you with.
Yeah.
Secondly, the question is, you mentioned fire return frequency being possibly too frequently for
recovery.
For recovery.
Yeah.
I would hope that in Australia, like in California, that there's some mechanism to adapt that fire return interval frequency. And so are you planning on adapting and educating people on what the most appropriate for the culture is for that fire return frequency?
Yeah. So I didn't have time to talk too much about that issue of fire return. So all of our different vegetation types have different tolerable fire intervals, and that's mainly around prescribed burning thresholds about, when you can burn. But wildfires or bushfires tend to be what imposes the return interval. So when you have large fires like this, they just overwhelm whatever sort of prescribed burning had been done. But certainly because of these fires, there's been a need to adapt the prescribed burning plans. The other thing to point out is that these tolerable fire intervals, they haven't to date really dealt with this issue of fire severity, and particularly with cultural burns or prescribed burns, they're lower intensity than wildfires. And so that is work that's ongoing now within the New South Wales Government to adapt these tolerable fire intervals to take into account this issue of intensity. And so potentially you could have more frequent burns if they're lower severity. Yeah.
One more question?
I was just wondering if you could touch on the media coverage of Black Summer in Australia and maybe even globally, and what you thought was missed, what you thought got right. I think there was like a very distinct message of total apocalypse being received, and so it's quite interesting to see you present more nuance.
Yeah, look, that was definitely the case. So we just had blanket coverage in Australia, and it was very much apocalyptic. This is climate change. We had, the Sydney Opera House was covered in smoke. People were wearing masks in our biggest city. It was very distressing. And what a lot of people missed was fundamental fire ecology, that many of these ecosystems need fire. And so in many cases, the fire is a good thing, but of course, in many cases, the fire is a bad thing. It's very difficult to know how drought is overlaying with that. And because we had we had COVID, then we had 3 wet years in a row, and we had floods, the vegetation looked green, and so everyone just thought, oh, it's recovered, it's fine. But often that greenness, if you look closer, it's not recovery. you know, some of the trees may not be coming back, some of the species may not be covered back, but it's just, none of that is covered in the media. It's just very much the fire's on, fire is bad, it's raining now, we don't have to worry about fire. Yeah.
Thank you.
Thank you.
Okay. The controversy for the next speaker, many don't know that Diego and I are actually brothers. So which one's the handsome brother? Diego is going to talk about integrated fire management. What do we need to know, and how do we know it's enough?
Thank you so much, brother. And it all stays in the family. Yeah. So don't forget to take pictures. Family's going to request them. Let's start with my talk now. And let me just show you these beautiful pictures of the monarch butterfly migration event that you may be well aware of. And that is that many monarch butterflies from the eastern part of the US and Canada travel every year to this forest in Mexico. And they come to a biosphere reserve, which is called the Monarch Butterfly Biosphere Reserve, which, of course, has, you know, it's a forest. They always come to these same sites. And I'm glad that Rachael talked about fire events and infrequent fire events. This biosphere reserve is 56,000 hectares. And that's the size of many of the big fires that you have experienced in California, the US, and Canada. So I just figured, well, what happens if this biosphere reserve burns down in a single fire event? And where are we going to hide our heads in Mexico if something like that happened? As you can see in the panel in the bottom right, trees have experienced fires. We know that. We have fire scars in the trees. So how do we know that this fire is not going to burn, and what can we make to make sure that this doesn't happen? And who is going to manage the landscape here? So all those are pertinent questions that I wanted to address about 15 years ago, and I've been working on them ever since. So once again, this just to talk a little bit about the monarch butterfly migration event, this phenomenon was actually described by two Canadian scientists, the Orkwards, and basically what they described was not the monarch family, the monarch butterfly per se, but actually the migration pattern. And they were able to document how these populations coming from the eastern part of the North American continent came to this small patch of forest in Mexico. So basically, I want to talk about how can integrated forest management be done here, and what do we need to know, and how do we know it is enough? You know, because we have new challenges coming all the time. So let me just tell you something very quickly about the Monarch Butterfly Biosphere Reserve. As I mentioned, it's about 56,000 hectares. It's divided into two core zones, so one little separated patch on the right hand there, and then the much larger space here. It has three core areas in which people are really restricted on what they can do. And then they have two large buffer zones in which forest management can be conducted. This area is actually quite emblematic. You know, it's part of the New Mexican volcanic axis. It has forests that you may be familiar with. It has pines, oaks, abies, firs. But what's different about this is that they are at 2,000 meters elevation. One more thing, which is it's very diverse. We have different vegetation types, more than 700 species of vascular plants, several species of endemic plants to Mexico. But this place is also home to more than 27,000 people. You see, this biosphere reserve was actually declared in 2000. And it wasn't created in a place which was devoid of people. It was created on top of people that actually own the land. So these people have been conducting several forest management practices for a long, long time. And this has most certainly affected fire regimes and the way that fire takes in the place in the area. To make life a little bit more complicated, this is just a map that describes within the biosphere reserve how the land is divided across different properties. So we have more than 103 properties. 63 of them are ejidos, and ejidos are a private property type which is communal. So basically, a whole bunch of people own a piece of land, and you know how fun it is to work in those conditions. you have 12 comunidades indígenas. I on purpose left this name in Spanish because I'll talk more about what indigenous means and indigenous communities in this context. But basically, we have 12 comunidades indígenas in this place, 1 federal property, 1 state property, and 26 small holdings. So it's a very complex mosaic of land properties here, and we all need to manage this to make sure that this doesn't burn down eventually. So some of the first things that I did, and Rachael already did this for me too, was to describe, well, what the fire regimes are in this place. What should we be aiming to in terms of what the natural fire regime is and how can we approach this fire regime with fire management practices. Let me just say one more thing about this site. In red, we have the mean temperature, and on blue, we have precipitation. On the left axis, we have the millimeters, and on the right axis, we have mean temperature. As we can see, the mean temperature here in this forest, this comes from a station in Zitácuaro, which is a city close by. You know, we don't have very harsh winters, you know. Our mean temperatures goes between 15 and 20 degrees Celsius. And if you're jealous, I would understand you, okay? We Mexicans are very spoiled. Our winters, you know, we have perhaps temperatures of 5 degrees Celsius, and we put scarves, gloves, and sweaters. And, you know, for our summers, yeah, we have maybe 25 degrees. So we don't understand why people live elsewhere in the world, but that's, you know, the reality here. And the other part, which is important to underline, is what happens with rains, because, of course, during the rainy season, we have no fires. In fact, right after the rainy season, in October, November, December, is what I call the cold winter, and almost no fires there. But then we have February, March, April, and those are the months that we have to take care of fires. So those are, you know, as much as fire season goes, those are the months that we have to be really careful about fires in this site. So once again, under the assumption that if we follow fire regimes, we'll be keeping the conditions which are ideal for ecosystem integrity, we need to first find out how the local inhabitants manage fire. You know, we knowing that Homo sapiens is an essential part of this ecosystem. What are they doing with fire here? And it's going to take a second here to thank all these people in this list, which are students that have come through my lab, and they have conducted part of the research that I'm going to be describing to you. So let's start first with how do authorities manage fire? And can we just use the records and see what they have done with fires in the past 20 years and use the records to rebuild fire management practices and fire regimes? So the first thing we did was actually to visit some fires in 2012 and see what the authorities reported, where they took place and what sizes they were. And sure enough, we actually got a surprise. Like for some of the fires, they were within 1 kilometer of distance to where they were reported. But for some fires, they were more than 20 kilometers away. And of course, when you know this, you don't know exactly which fires are going to be misplaced within the fire records. So now you cannot really trust the fire records very well. Not only that, but in terms of sizes, fire brigades for some reason tend to overestimate the size of fires. Except for one particular case in which a fire that was actually very close to 20 hectares was recorded as 2 hectares. So if any of you has worked on fires, you know that it's very easy to report at the end of a fire the size of the fire, and somehow you missed a 0. So something like that must have happened. So again, if we just look at these historical records, it's not easy to trust the information, so we had to kind of rebuild it again. By the way, recognizing these issues, we actually taught a little course to fire brigades in the region on how to use the GPS and make sure that they could use these instruments to better record the fire history. The second thing that we did is that this is what the sources of ignition that they have declared. And as you can see, usually it's agricultural escapes what they blame on fires. All the rest of the causes actually are more, you know, all are human-induced. Most of the causes have to do with human activity, of course, but actually if you add the frequencies of the other columns, you know, you have actually more fires by other causes rather than agriculture. So we really want to see whether agriculture was the real culprit here. So one of my students, Leonardo Martinez, in 2016, actually interviewed a number of families to make sure he understood how they actually made use of fire within the Biosphere Reserve. He actually visited more than 17 localities, 2 indigenous communities, and 15 ejidos. and he interviewed more than 44 family units, and this was, really profound interviews and going with them to the field, so on and so forth. And to make a long story short, we found out again that they use fire for a number of issues. In fact, for agricultural purposes, we found that the main reason they use fire is actually to get rid of an introduced grass that comes from Africa, Panicum clandestinum, and they use it for horses and cows. And it's actually the spread of this grass that is causing agricultural burning more than anything else. And unfortunately, there isn't much documentation on how this grass is spreading on the biosphere reserve. We actually found that there are 4 major fire uses, basically for agriculture, for animal husbandry, for forest management, and for road and canal water maintenance. One thing which is very important is, again, Mexican legislation today actually makes it very hard for farmers, for campesinos, for peasants, to actually use fire with the excuse that they are going to cause forest fires. What we found is that they actually know very well what they are doing. They actually do burn very well, with these mounds or with other practices, but this knowledge actually is not passed through universities or books. It's passed from, family, right, So, from parents to children, so from mothers to daughters. So if we actually interrupt this passage of knowledge through legislation by not allowing people to burn, then we're going to lose all this empirical culture of how to use fire. And to me, the cost of that will be far more problematic than the current condition. So it's very important to value that knowledge, to appreciate it, and actually to use it to promote better fire management practices. One more thing which is important here, and I have to put this slide because people were worried, is what fires do to the monarch butterfly migration. What I have put here is when people report that they did agricultural fires, and then in the line we have when most forest fires actually happen. And as you can see, there is a mismatch. They are not coordinated. So actually, and not only that, but the time when the monarchs are in their sanctuaries corresponds with the time when people are actually doing agricultural burning. So if this has happened for the past, 50 years, I don't think that the monarchs really care much about agricultural burning. In the lower parts of the biosphere reserve, they are still arriving happily to the top part of the mountains, apparently. Now, I want to stop here. If it's so important to talk about agricultural fire, let me just say a few words about original cultures in Mexico, because I think it's key, and also to talk about some terms. Well, Mexico is a very diverse country, not only in terms of biodiversity, but also in terms of cultural diversity. It's a Babylon center. It's one of the centers where agriculture was created with the rest of Mesoamerica. One more thing which is important is that 13% of Mexicans consider themselves part of an original culture. And here, I would like to say something that has caused me trouble in video conferences with colleagues working with these themes, because if we call them Indians, is wrong, of course. Please don't do that. It's very pejorative, and it comes from a confusion from half of my ancestral genes coming from Spain 500 years ago, and thinking that they were arriving to India. So that's why it took the name as Indians, to native or original cultures here. And then we call them indigenous people, but indigenous actually has roots, which means Indi, as from the place, and genus, to reproduce. So technically speaking, I'm also indigenous to Mexico, although I may not have the heritage of an ancestral culture. So with my students in my lab, some of whom come from Oaxaca and other indigenous places, they actually feel attacked when you call them indigenous people. So they like the term original cultures better. So through the rest of the talk, I'm going to talk most about original cultures rather than indigenous people, but this is something that may be particular either to my lab or to Mexico, but now the term we use is original cultures more than anything else. But what's important about this diversity culture is that I don't think we have made an effort to characterize the diversity of fire usages by all these cultures, and that's something that we should be tackling. This is very important because 80% of forest resources are in the hands of ejidos or original cultures in Mexico. So it's really key that we understand these issues. By the way, a few years ago, a Mexican social scientist, Miguel Ángel León Portilla, actually published a very important book, actually almost on the face of the Mexican government, you know. It's like saying, well, we have been independent for 200 years, and what has happened to the original cultures? So he said, ¿y los indios qué? He was trying to be, again, pejorative, you know, to the Mexican government. And I want to stress one of the major points of this, of the facts of this book, that is that Mexico actually had a much higher population of original cultures much before the arrival of the Europeans. Density, human density decreased after when we became independent from Spain. And we suffered several wars during the 19th and early 20th century. But one of the results of all these social processes is that, unlike in the US, original cultures in Mexico don't have reservations, don't have land in which they can impose their own legislation. All original cultures in Mexico are Mexicans by definition. So they have to act according to the Mexican laws or state laws. And that actually sets a very different, for example, if you were to look at how cultural people do burning, they will have to do it not within the reserves, they will have to do it within the Mexican legislation too. And that's actually very different from what happens in the US, not to mention Canada, where you have the Inuit, the Métis, and you know, the First Nations. So recognizing this and knowing that we already made, some understanding on how people use burning in the Biosphere Reserve. Within the Biosphere Reserve, we have two original cultures. We have the Mazaguas, we have the Otomis, and then we have people that don't have any cultural affiliation with original cultures. So now I have a PhD student who is looking into towns or localities with our Mazagua, which are Otomi, and which are not Mazagua nor Otomi, both inside and outside the Biosphere Reserve, and try to describe what their burning practices are. So please stay tuned for the next results of that PhD thesis that should be done sometime this year. Well, not this year, 2024, I hope. So again, this is just the locations where she is doing her work. Now we have asked the people, let's ask the trees. And I see a good number of people here that have taught me about this. Basically, Jesus Eduardo Sáenz-Ceja, who is going to give a talk on Thursday, did most of this work as part of his dissertation. And the first thing to do is to recognize that if we are working in the mountains, we have different elevations. And as you go up into the mountains, you change dominance from pines, Pinus pseudostrobus mostly, and then you turn into fir, Abies religiosa, which is where the monarchs arrive. And you have a transition zone almost at 3,000 meters of elevation. So do fire regimes differ in these two dominance, three dominances? Do we have different return intervals? How often do they burn? Well, using typical endocrinological techniques, basically we we sample trees in this higher zone, in the middle zone, and the bottom zone of the Biosphere Reserve in fir and pine forest. And there are several things that I want to outline out of this slide. And I'm sorry, the numbers are very small, but the first thing is that these are really tropical montane forests, although we share the same genera that you have here in the US and even in Canada. We don't really have harsh winters, so trees actually grow faster. And what's interesting is that if you do this dendrochronological research, we only found very few trees which are more than 150 years old. If you do the same research here in California, you can find trees which are 400 years, 500 years. But here we only found 150 years, it was kind of surprising. Second thing to point out is that the reserve was declared in 2000, which is almost the last axis on the x-axis. And you can see that there's plenty of fires before then and after then. So declaring the Biosphere Reserve apparently has not affected the occurrence of fires. Also, if we look at the time in which trees actually got established and the relationship with dry years and fire years, we find no relationship. So apparently both these trees, we suspected that fir trees would actually require large fires to regenerate. But no, they apparently, just as pines do, they regenerate continuously and apparently are not related to the occurrence of fires. So with all this information, social information and ecological information, we actually developed an integral fire management plan with the help and with the participation of local inhabitants. And unfortunately, this plan was developed about 6 years ago, and it hasn't really been implemented. which is not our fault. This has to do with the authorities of the Biosphere Reserve. So why not? And what can we do as scientists to make sure that all this knowledge is not thrown away and is actually implemented and used? So I want to point at the next part of the talk, and exactly what we know now that we didn't 10 years ago, and is this enough to actually implement a fire management plan? And the answer is no, we need to do more. In fact, in 2018, we had several fires. We had never had a fire of 80 hectares in the Biosphere Reserve. We hit a threshold in 2018. So these are some pictures of that particular fire. And well, what we did actually was this is a different fire in a different city, but the two photos on the left are right after the fire, and the right is 1 year after. What we did is we have taken people to do this exercise, to visit places that have burned, so they can know, they can see how the forest regenerates. And sometimes by doing interventions to promote regeneration, we actually be doing more damage to the forest. So it's very important to give this message across. And as we have working there, we actually have seen some emerging threats. And this is one in particular that really scares me. I hope you all like guacamole. It's something that I really like a lot. And you may know that to prepare guacamole, you have to have avocados. And the major producer of avocados worldwide is Mexico, and the major producer within Mexico is Michoacán, which is the state where I work and where I live and where the reserve is at. So the problem with that is that now there is such a huge demand for avocados that pine and oak forests are disappearing. And now we have avocado farms or avocado orchards in several portions, in the lower portions of the Biosphere Reserve, within the Biosphere Reserve. And what's the problem with this? Well, avocado, as you know, is a hybrid. The one that you buy in the market has avocado. So there is actually very little genetic diversity within that crop. So it's really intensive in terms of the pesticides that you have to use. And mind you, this is insecticides that you're using in a Biosphere Reserve that was created to promote and to preserve an insect, which is the monarch butterfly, right? So I'm really worried about what may happen in the future with expansion of avocados in the Biosphere Reserve. And not only is this an issue of the expansion of the orchards, it's also an issue because of the fact that to create these orchards, you actually burn forest. Not only to do land use change, but actually because you may burn an area in place A, so you can cut the forest in place B, while all the authorities are putting down the forest in place A. So it is a real issue, something we do worry a lot. So new challenges, avocado expansion, new uses of fire, and of course, violence. There was a report about last week about the violence related with illegal production of narcotics in several parts of Mexico and the relationship with cleaning capital of laundering money, through avocado. And how is this affecting the region? Well, there are some places where actually I'm really careful about traveling with my students nowadays that I didn't used to be that careful 10 years ago. And of course, an issue that I didn't think about 10 years ago is actually the turnover of local officials. One of the reasons why this plan has not been implemented is because we actually experienced the change of the new director of the Biosphere Reserve. So the new person kind of didn't have that on top of his desk. So it's an issue of how to deal with this, so we ensure that all this knowledge doesn't get thrown away every time there is a change in authorities within the places. So how do we solve that? And I guess the only answer I can give now is all the answers to new challenges. Of course, talk about social organization, do transdisciplinary research, work with the people, because that's the only answers that I can provide today if we want to find issues and how to solve the problems of the expansion of fire in the region outside of what we have experienced historically. Well, I'd like to finish again with some pictures of local burning and give credits to the different pictures that I've shown through the presentation. I really want to thank the different agencies that funded my research. I'm sure that Rachael can also acknowledge them if she wants to, but these are agencies that funded my research. Thank you very much. And with that, thank you so much for the opportunity to put all these different small stories together in a single story. Thank you so much for the invitation to take this plenary, and I'll be happy to answer any questions. Thanks a lot for your time.
We have plenty of time for questions. Yeah, if we're good for,
Yeah, we have
we can
time.
take a couple of questions. Nothing commenting who the more handsome one is now that we're standing so close together.
Questions for Diego?
Everything was clear? I cannot believe it.
Back to the far right, Jeff.
Can't see. Oh,
Yeah. Yeah, I know. Yeah, many of the monarchs in the western part of the U.S. don't migrate to Mexico. They actually stay here in California, which is all right. We still like them. Yeah, but yeah. So, thank you for your comment.
Can you hear me? First, I wanted to thank you for converting me from an avocado addict to now an organic avocado addict. I hope that makes a difference. Second, I had a question. Since you do the dendrochronological work with this, do you have an idea of the fire return interval and the fire regime in that part of the biosphere reserve?
Yeah, thank you. I guess I didn't mention it. It's about every 3.5 years is the fire return interval. So it makes perfect sense to have, very low severity, low intensity fires returning very often. And this is basically what apparently the forest has been adapted to, at least for the past 150 years.
And
That's what we think it happens, yeah.
Was that fire return interval associated with cultural burning, or was that natural ignitions? Do you know?
Great question. I don't know. I think that it was, it's hard to know, because 150 years doesn't really give you too much depth to understand how the different populations may have affected this. Let me tell you some things that I didn't put in the presentation, what we know about this place. In fact, knowing that the population of Mexico actually decreased after the arrival of Europeans, I wouldn't be surprised if the population in this side was actually quite as high as it is today, maybe 500 years ago. We know that there was a very big fire about 300 years ago, and we know that because there were some landslides in the region in 2016. And 2011, I'm sorry. And one of the students in my lab, actually doing her master's, got some samples of carbon accumulation, and she dated them, and it came about that age, about 350 years ago. So our interpretation of that is that maybe there was a huge, massive, fire in that time, which would coincide with actually the decrease of the density of people. Because it's after the arrival of the Spaniards, decrease in the number of people, you wouldn't have people managing the ecosystem. You have, an special fire, and then it booms, it burns a larger area. But this is all pure speculation. Sorry about that.
Thank you, and quickly out of curiosity, was that 300 years ago fire, was that 1748, which coincides with a massive amount of fire in North America as well?
I'll check the date, because I don't remember by heart. I think it was more like 1730-something, but I will check.
Thank you, sir.
Sure. Thanks.
Thank you.
No more questions?
No, none for you, buddy.
Okay.
Thank you. Well, thank you again.